The dust still clung to the olive-drab hull as Major Hans-Georg Lueder circled the captured American tank in the fading Tunisian twilight. It was February 22nd, 1943, and his unit, Schwere Panzerabteilung 501, had just seized an intact M4 Sherman near Sbeitla after the rout of inexperienced American forces. War Daddy 2 read the white lettering still visible on the turret side. Lueder ran his gloved hand along the cast hull, noting the quality of the welding, the precision of the assembly. His Tigers had dominated the battlefield that day, their 88mm guns punching through American armor with ease. 20 M4s destroyed, the Americans fleeing in disarray. But standing here, examining this machine up close, Lueder felt something unexpected. Not contempt, curiosity. "Get the spare truck ready," he ordered his second-in-command, Hauptmann Werner Schmidt. "Berlin wants this one intact. We're driving it to Tunis." Schmidt raised an eyebrow. "Sir, we have Panthers coming online. Why waste time studying inferior American equipment?" Lueder didn't answer immediately. He'd climbed inside the commander's hatch, disappearing into the turret. His voice echoed up from below. "Schmidt, get in here. Now." The interior smelled of oil, sweat, and something else. Something that would haunt German tank designers for the rest of the war. Efficiency. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The journey from Sbeitla to the port at Sfax would cover 350 kilometers, 4.5 days of driving through enemy territory, nursing the captured Sherman along rutted roads, conserving fuel, praying the engine wouldn't fail. The fact that they even attempted it revealed how seriously the Wehrmacht took this prize. Unteroffizier Klaus Hoffmann, a 23-year-old gunner who'd worked at a Daimler plant before the war, was assigned to drive. As he settled into the driver's seat that first morning, he noticed something that made him pause. "The controls," he called up to Schmidt. "They're simple, too simple." "What do you mean, too simple?" Schmidt replied, impatient to get moving before Allied aircraft appeared. "Our Panthers, our Tigers, they require extensive training just to operate the transmission properly." Hoffman's hands moved over the Sherman's controls experimentally. "Fighter, anyone could drive this. A farm boy, a factory worker. It's brilliant." The engine started with a reassuring rumble, not the temperamental, finicky ignition sequence of German tanks that required careful coordination between driver and engine. Just a simple starter motor that worked. They rolled forward. The suspension absorbed the rough terrain with ease. The visibility from the driver's position was excellent, far better than the cramped, limited view in a Panzer IV. Hoffmann found himself accelerating, taking corners, all without the grinding protests he'd grown accustomed to in German armour. "This shouldn't be possible," he muttered. "We weigh 30 tons. It handles like a racing car." By the second day, word had spread through the column accompanying the Sherman. German tankers found excuses to examine it during rest stops. They studied the engine compartment, where the Ford GAA Vate sat with its 450 horsepower, cooled by a simple but effective system that actually worked. Obergefreiter Otto Brandt, a Maybach engine specialist, spent an hour with his head buried in the machinery. When he emerged, his face was troubled. He reported to Lueder, who'd been monitoring their progress. "This engine? It's crude by our standards. Large tolerances, simple construction. And it will run forever. We build engines like Swiss watches, precision, tight tolerances that require perfect maintenance. They build engines like agricultural equipment, rough but reliable." "You're saying it's inferior?" Brandt hesitated. "I'm saying it's designed for a different purpose. We build tanks for elite crews who can maintain them properly. They build tanks for mass armies who need them to simply work." On the third day, they encountered mud. The spring rains had turned a section of road into a quagmire that would have stopped a tiger in its tracks. The Sherman's tracks, wider in proportion to its weight, carried it across with barely a pause. "How is this possible?" Schmidt demanded, watching from a sidecar motorcycle as the Sherman navigated terrain that would have required recovery vehicles for their heavy tanks. A Panzer III commander who'd been observing provided the answer. "Ground pressure. The Americans designed this for global warfare. Pacific Islands, Russian mud, North African sand. We designed our tanks for European roads." That night, camped in a ravine to avoid Allied reconnaissance, Lueder gathered his officers around the Sherman. "I want honest assessments," he said. "Not what you think Berlin wants to hear. What do we actually have here?" The armor officer went first. "Armor is adequate, not exceptional. Frontal plates are well sloped, though. Clever use of angles to maximize protection without excessive weight." The gunnery officer added, "The 75mm gun is inferior to our long 88, but the turret traverse is electric, fast, very fast, and it has a stabilizer that allows firing while moving." "Firing while moving?" Lueder's interest sharpened. "We've been trying to develop that for years. It's rudimentary, not perfect," the officer qualified. "But it works. In the confusion of combat, being able to fire while maneuvering, even if accuracy suffers, is a significant advantage." Schmidt compiled the list. Positives: reliability, ease of maintenance, good ergonomics, excellent visibility, rapid production potential. Negatives: armor inferior to our Panthers, gun lacks, penetrating power against heavy German armor. "The question," Lueder said quietly, "is whether those negatives matter if they can produce 50 Shermans for every one of our Tigers." Silence fell over the group. No one wanted to voice the implications. They reached Sfax on February 27th. War Daddy 2 was loaded aboard a cargo ship bound for Germany, still bearing its American markings, still wearing the battle scars from Sidi Bouzid. The journey across the Mediterranean felt like transporting a secret that would change everything. At Kummersdorf Proving Ground, 25 kilometers south of Berlin, Oberingenieur Friedrich Müller had been waiting. As head of enemy tank evaluation for the Waffenamt, the Army Weapons Office, he'd examined captured French, British, and Soviet tanks. But this was the first American medium tank to arrive intact for comprehensive testing. The date was March 19, 1943. Spring had come early to Brandenburg, the forests surrounding Kummersdorf alive, with new growth that contrasted sharply with the grim business conducted within the Proving Ground's extensive facilities. War Daddy 2 received the designation Versuchsfahrzeug 259, Test Vehicle 259. A license plate was welded on, WH058941. Then came the meticulous work that would occupy Müller's team for months. They began with dimensional analysis. Teams of engineers measured every surface, recording armor thickness in millimeters and angles in degrees. These measurements were stenciled directly onto the tank in white paint, transforming War Daddy 2 into a walking technical diagram. Glacis plate, 51 millimeters at 47 degrees. Turret front, 76 millimeters, rounded. Side hull, 38 millimeters, vertical. Interesting, Müller noted in his initial report. The Americans prioritize production simplicity and sloped armor over raw thickness. The glacis angle nearly doubles, effective protection without the weight penalty. But it was what happened when they started the engine that began changing minds. The Ford GAA fired up immediately, no temperamental starter, no finicky warm-up procedure, just turn the key and go. Müller, who'd spent years troubleshooting Maybach engines that required careful nursemaid, stood listening to the smooth rumble with growing unease. "Run a durability test," he ordered. "Standard protocol. We'll compare it to our own tanks under identical conditions." The durability testing would reveal truths that German high command wasn't ready to hear, but that would come later. For now, Müller assembled his evaluation team, some of the Wehrmacht's best automotive engineers, mechanics, and armor specialists. Hauptmann Dieter Kraus, formerly of Porsche and now responsible for transmission analysis, was first to crawl beneath the Sherman. He emerged 2 hours later, covered in grease, his expression conflicted. "The transmission is simple," he reported, "almost primitive by our standards, but it's accessible. A crew could remove and replace it in the field with basic tools." "And ours?" Müller prompted. Krauss's silence spoke volumes. German tanks required specialized workshops and trained mechanics to service their complex, precision-built transmissions. Oberleutnant Hans Werner, an optical specialist, examined the gun sights. The periscope arrangement provides excellent visibility. The gunner's sight is adequate. Nothing exceptional, but the key is ergonomics. Everything is positioned for rapid target acquisition. The armor metallurgist, Dr. Karl Schmidt from Krupp, took samples for analysis. His findings would be detailed in a separate report, but his preliminary assessment disturbed the team. "The armor quality is inconsistent," he noted. "Some plates are well hardened, others less so. But here's the critical point. It doesn't matter. They're accepting good enough armor and compensating with angled protection. Our insistence on perfect metallurgy slows production dramatically. Each day brought new discoveries that challenged fundamental assumptions about tank design philosophy. The suspension system, examined by Obergefreiter Martin Koch, proved remarkably durable. The vertical volute spring suspension is simple, almost crude, but it's robust, easy to repair. Any mechanic can work on this." The comparison to German torsion bar suspension was implicit. More sophisticated, yes, but requiring specialized tools and expertise to maintain. Werner examined the turret basket, the crew positions, the ammunition storage. "They've designed this for average soldiers, not specialists. The loader can operate effectively even under stress. The commander has excellent visibility. It's not elegant, but it's effective." What truly shocked the evaluation team emerged during the first week of operation testing. They ran the Sherman through Kummersdorf's standard obstacle course, the same route it's used to evaluate Panthers and Tigers. The Sherman completed the course without issue. More importantly, it completed it quickly. The power-to-weight ratio, that critical metric of mobility, favored the American tank dramatically. 15 horsepower per ton, Müller noted, comparing figures. "Our Panther achieves 13, our Tiger barely 12.5. They're more mobile than our newest designs." But it was the reliability testing that delivered the most devastating verdict. Standard procedure required running each test vehicle through a 200-kilometer trial under varying conditions. Roads, cross-country, mud, hills, maximum speed runs. Most German tanks, even the newest Panthers fresh from the factory, developed issues during this test. Transmission problems, cooling failures, suspension breakages. The Sherman ran for 200 kilometers without significant issue. They extended the test to 500 kilometers, still running. At 1,000 kilometers, Müller called a halt not because the Sherman had failed, but because they needed to begin destructive testing. The engine still purred. The transmission still shifted smoothly. The suspension showed wear but remained functional. "This is impossible," muttered Krauss, examining the transmission after the test. "No German tank runs 1,000 kilometers without major mechanical issues. The Panthers are breaking down at 150. Müller's preliminary report, classified at the highest levels, contained a single devastating sentence. The American M4 Sherman represents a fundamentally different approach to armored vehicle design, prioritizing operational reliability and ease of production over individual vehicle superiority. The implications hung in the air like cordite. If the Americans could build 50 reliable Shermans for every German Tiger, if those Shermans actually worked in the field while German armor sat immobilized awaiting parts and repairs, then Germany's vaunted technical superiority might be strategically meaningless. In April of 1943, something unprecedented happened at Kummersdorf. Albert Speer, Reich Minister of Armaments and War Production, personally visited to inspect the captured Sherman. Speer climbed into the commander's hatch, settling into the seat. For several minutes, he simply looked around, studying the controls, the visibility, the ergonomics. His face revealed nothing, but those who knew him recognized the calculating expression of a man confronting uncomfortable truths. When he emerged, he spoke briefly with Müller. The conversation was never officially recorded, but Müller's notes from that day survive. The minister asked 3 questions. Can we copy it? Should we copy it? Why didn't we build something like this first? I had no good answers. Speer's official report to Hitler emphasized the Sherman's weaknesses: inferior armor to Panthers, inferior gun to Tigers, inferior engineering to German standards. But buried in appendices were observations that Speer understood even if others didn't. The Sherman's primary advantage lies not in its combat specifications but in its industrial design. It is built to be manufactured, maintained, and operated by average personnel. Our tanks require specialists at every level. The testing continued through spring and summer of 1943. Each week brought new data, new comparisons, new uncomfortable revelations. The fuel consumption tests showed the Sherman used less gasoline per kilometre than any comparable German tank, critical, given Germany's chronic fuel shortages. The maintenance hour requirements demonstrated that basic Sherman upkeep required 1 mechanic working 2 hours per 100 hours of operation. A Panther required 3 mechanics working 4 hours for the same period. A Tiger, 5 mechanics for 6 hours. We're not comparing tanks, observed Werner during one evening discussion. We're comparing industrial philosophies. We build weapons for a short, victorious war. They're building weapons for a long, grinding conflict. The propaganda magazine Die Wehrmacht published an article in June of 1943, carefully crafted to acknowledge the Sherman's capabilities while maintaining German superiority. The wording was revealing in what it both said and didn't say. The preliminary investigation on Tunisian soil already showed that this rolling steel mine is not in itself a bad creation. It is quite a praiseworthy product of the North American steel industry, one of the special accomplishments of North American laboratories. Praiseworthy, not dangerous, not superior, not threatening, just praiseworthy. But in the workshops of Kummersdorf, where engineers and mechanics dealt with reality rather than propaganda, a different truth was emerging. Late one night, Müller found Hoffmann, the driver who'd brought War Daddy 2 from Tunisia, sitting beside the Sherman. "What are you thinking, Hoffmann?" Müller asked. The young Unteroffizier chose his words carefully. "I drove this tank 350 kilometers through enemy territory. It never faltered. I've driven Panthers that break down after 50. I've seen Tigers abandoned because a single road wheel failed and we didn't have replacements." He looked up at Müller. "Aber, sir, which tank wins the war? The perfect one that doesn't run, or the adequate one that keeps running?" Müller had no answer. Or rather, he had an answer he couldn't voice. Not officially. Not where it might be reported to the wrong ears. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The summer of 1943 brought a shift in testing priorities. Germany was preparing for Operation Zitadelle, the massive offensive at Kursk. Panthers were being rushed to the front despite ongoing mechanical issues. Tiger battalions were being reinforced. The Wehrmacht needed to understand how German armor would fare against not just Soviet tanks, but the possibility of American ones. Comparative ballistic testing began in earnest. War Daddy 2, which had survived its operational testing remarkably intact, would finally face German guns. The testing protocol was standardized. Engagement at various ranges with different ammunition types, recording penetration capability, armor performance, and post-penetration effects. At 500 meters, the Panther's long 75mm gun, the KUK-42, punched through the Sherman's frontal armor cleanly. Expected. At 1,000 meters, the same result. The Panther's gun was formidable, but then they ran the test in reverse. The Sherman's 75mm M3 gun, firing M61 armor-piercing rounds, couldn't penetrate the Panther's frontal armor at any practical range. Also expected, the Panther had been designed specifically to counter Soviet armor. Yet, the test revealed something subtle, something that wouldn't appear in official reports but that combat veterans understood instinctively. The Sherman's turret traverse was electrically powered and far faster than the Panther's manual traverse. In a tactical scenario, the Sherman could acquire targets faster, could shift fire between threats more rapidly. In a duel on open ground at long range, the Panther wins decisively, Müller summarized. But combat isn't a duel, it's chaos. Fast target acquisition, rapid maneuvering, working in coordinated groups. These are the Sherman's strengths. Dr. Schmidt, the metallurgist, had completed his analysis of the Sherman's armor composition. His report contained an observation that seemed almost envious. The Americans have accepted variability in armor quality to maintain production speed. Some plates test as well as our best armor, others are merely adequate. But adequate, produced in quantity, may be strategically superior to perfect, produced in small numbers. This philosophical divide, adequate versus perfect, ran through every aspect of the evaluation. It represented two completely different approaches to industrial warfare. German engineering tradition valued precision, perfection, superiority in every individual component. The mindset that produced Mercedes-Benz cars, Leica cameras, and Krupp steel, quality over quantity. American industrial philosophy valued adequacy, reliability, and mass production. The mindset that produced Ford cars, Caterpillar tractors, and standardized everything, good enough in overwhelming numbers. By August of 1943, Friedrich Müller had compiled enough data to write his comprehensive report, 312 pages of technical analysis, comparative testing results, and strategic assessments. The document represented months of meticulous work by Germany's best automotive engineers. The conclusions were damning. Müller sat in his office at Kummersdorf, reviewing the executive summary one final time before submitting it up the chain of command. Outside his window, War Daddy 2 sat on the proving ground, still operational after 8 months of intensive testing. Nearby, a newly delivered Panther awaited evaluation, already showing oil leaks from its troubled final drive. The contrast wasn't lost on him. His summary read, "The M4 Sherman medium tank represents American industrial warfare philosophy made manifest. While inferior to German designs in armor protection and main armament, the Sherman achieves strategic superiority through operational reliability, ease of manufacture, and simplified maintenance requirements. Current German tank development prioritizes individual vehicle combat capability over systemic effectiveness. If American production reaches predicted levels, numerical superiority of reliable vehicles may overcome German technical advantages." He signed the document, stamped it, Geheim, secret, and sent it to Berlin. The response came 3 weeks later, not from technical branches of the Wehrmacht, but from the Reich Ministry of Propaganda. The report was to be contextualized. Certain conclusions were to be refined. The overall assessment needed to better reflect German technological superiority and inevitable victory. Müller understood the subtext. Tell us what we want to hear, or tell us nothing at all. He wasn't surprised. He'd seen this pattern before with evaluations of Soviet T-34 seconds captured in 1941. German engineers had accurately identified the T-34's revolutionary design features and warned that Soviet tank philosophy posed serious threats. Those warnings had been dismissed as defeatism. Now, 2 years later, Panthers and Tigers were being rushed into production specifically to counter the T-34. The warnings had been correct. They'd simply been ignored until crisis forced acknowledgement. Would the same happen with the Sherman? Hauptmann Kraus found Müller that evening in the Miller, testing hangar. The transmission specialist carried a folder thick with documentation. "I've completed the comparative reliability analysis you requested," Kraus said, spreading charts across Müller's desk. The results are worse than we thought. The data painted a stark picture. German tanks, averaged across all models currently in production, achieved a mean distance between failures of approximately 400 kilometers under ideal conditions. Combat conditions cut that roughly in half. The Sherman, based on their extensive testing and captured American maintenance logs, averaged over 2,000 kilometers between significant mechanical failures. 5 times more reliable, Müller said quietly. In practical terms, 1 Sherman equals 5 German tanks simply by remaining operational. It's worse than that, Krauss continued. Repair times. When a Sherman breaks down, the crew can often fix it themselves with basic tools. When a Panther's final drive fails, ISEAA, which happens constantly, it requires specialized equipment and transport to a depot workshop. He pulled out another chart. I've calculated operational availability rates, the percentage of tanks actually combat-ready at any given time. For Sherman units based on American data, approximately 75%. For our Panther units in the field, we're seeing 30 to 40%. Müller leaned back in his chair, absorbing the implications. Have you shared this analysis? With you, and with Oberst Fischer at the Heereswaffenamt. Fischer's response was to question my methodology and suggest I was too impressed by American engineering. In other words, he didn't want to hear it. In other words, Krauss agreed, the truth is inconvenient. The psychological impact of the Sherman evaluation extended beyond Müller's immediate team. Word spread through Kummersdorf's engineering community. Young engineers, trained in German technical excellence, found their fundamental assumptions challenged. Oberleutnant Werner, the optical specialist, had been conducting interviews with German tank crews rotated back from Tunisia and Sicily. Their combat experiences with Shermans provided ground truth to complement Kummersdorf's laboratory findings. The crews confirm our analysis, Werner reported during a staff meeting in September. Shermans are individually inferior in direct combat, but the Americans use them differently. Coordinated attacks, combined arms, rapid maneuver. They don't try to outduel our Tigers. They use mobility and numbers to achieve local superiority. Like wolves against a bear, observed Dr. Schmidt. The bear is stronger, but the pack wins. Werner nodded. And here's the critical point. American tank crews are improving rapidly. The inexperienced units we faced in Tunisia were easy prey. By Sicily, they'd learned. They're adapting faster than we are. The comparison cut deep. German tactical excellence had dominated early war battles. But that excellence required extensive training, experienced crews, and time. Resources Germany increasingly lacked. American doctrine emphasized standardization and combined arms. Adequate crews in adequate tanks, supported by overwhelming artillery and air power, a system designed for mass warfare. We're fighting the last war, Müller said. We're building weapons for rapid, decisive victory through technical superiority. They're building weapons for industrial attrition, and we're losing the production race catastrophically. The numbers were undeniable. In 1943 alone, American factories would produce approximately 29,500 tanks. German factories, despite heroic efforts, would manage 11,000. The Soviet Union would produce an estimated 20,000. Germany faced a 40-11 production disadvantage, and their tanks were less reliable. In October of 1943, a Tiger company returning from the Eastern Front stopped at Kummersdorf for maintenance and refitting. Müller took the opportunity to interview the crews about their combat experiences. Hauptmann Ernst Baker, the company commander, had fought from Kursk through the subsequent Soviet counteroffensives. His Tiger had been knocked out twice, repaired each time, and was now on its third engine and second transmission. The Tiger is magnificent when it works, Baker told Müller over coffee in the officers' mess. The 88mm gun can destroy any enemy tank at ranges they can't even see us. The armor makes us nearly invincible from the front. But, Müller prompted, sensing the unspoken qualifier. But it works less than half the time. We have 10 Tigers in the company. On a good day, 5 are operational. Fuel shortages keep them immobile. Spare parts take weeks to arrive. The final drives fail constantly. And every breakdown requires recovery vehicles and depot-level maintenance. Baker stirred his coffee thoughtfully. I've seen captured Shermans, American ones and Lend-Lease ones in Soviet hands. They're everywhere. They keep running. When they're damaged, the crews repair them quickly and get back in the fight. When we're damaged, we're out of action for days or weeks. Which would you rather have? Müller asked. 10 Tigers with 5 operational, or 50 Shermans with 40 operational? Baker didn't hesitate. 50 Shermans. Because at the end of the day, the tanks that are actually fighting are the only ones that matter. This conversation, repeated in various forms with other returning veterans, reinforced what Kummersdorf's testing had revealed. Individual vehicle superiority meant little if those vehicles couldn't maintain operational readiness. By November, Allied forces had invaded Italy. American Shermans were now fighting German armour on European soil. Combat reports flowed back to Wehrmacht intelligence, and Müller's team analysed them carefully. The reports confirmed their predictions, with uncomfortable accuracy. In direct engagements, Panthers and Tigers dominated when they could bring their superior guns to bear. But those engagements were rare. More commonly, Shermans used terrain, smoke, and manoeuvre to avoid frontal duels. They attacked from flanks and rear. They worked in coordinated groups. They called in artillery and air support. They accepted losses, but kept pressing forward with fresh vehicles from seemingly inexhaustible reserves. German armour, magnificent in combat, achieved tactical victories that didn't translate to strategic success. They'd destroy 5 Shermans, 10 Shermans, but more kept coming, and each battle cost German tanks that couldn't be replaced quickly enough. Werner compiled combat loss analysis from Italy. Of German tanks lost, 42% are abandoned due to mechanical failure or fuel shortage. Only 38% are destroyed by enemy action. The remainder are destroyed by their own crews to prevent capture. Defeating ourselves, Krauss observed bitterly. Our engineering excellence is our weakness. Müller's second report, submitted in December of 1943, was even more explicit than the first. He'd titled it Strategic Implications of American Tank Production and Design Philosophy. The report argued that Germany's focus on technically superior but complex tanks was strategically counterproductive. It recommended immediate simplification of German designs, prioritizing reliability and production volume over individual combat capability. It suggested studying American production methods, their standardization, their acceptance of good enough quality standards to achieve higher output. It warned that continuing current policies would result in Germany having fewer operational tanks than the Allies, despite nominally superior designs. This report was classified even higher than the first. Geheime Kommandosache, secret command matter. Müller received acknowledgement of PB, a receipt, but no substantive response. Then, in January of 1944, he was summoned to Berlin. The meeting took place in a conference room at the Reich Ministry of Armaments. Present were Speer's deputies, representatives from the Heereswaffenamt, and several senior officers from the Panzer Inspectorate. General Major Heinz Guderian, Inspector General of Panzer Troops, led the discussion. Oberingenieur Müller, Guderian began, his tone neutral but his eyes sharp. Your reports on the American Sherman tank have been reviewed at the highest levels. Some of your conclusions have raised concerns. Müller remained standing at attention. Sir, I stand by every finding. The data is comprehensive and the analysis sound. No one doubts your technical competence, Speer's deputy interjected smoothly. The question is one of interpretation and strategic context. You suggest we should emulate American production methods, simplify our designs, accept lower individual vehicle performance. I suggest, Müller said carefully, that we acknowledge the reality of industrial warfare. The Americans will field thousands of adequate tanks that actually work. We're fielding hundreds of superior tanks that break down constantly. Guderian's expression didn't change, but something flickered in his eyes. Recognition. A man who'd pioneered armoured warfare understood the truth being spoken, even if he couldn't officially acknowledge it. Your technical assessment of the Sherman's capabilities is noted, Guderian said. However, strategic decisions must account for factors beyond mechanical reliability. German tank crews are superior. Our tactical doctrine is proven. These advantages offset numerical disparities. It was a polite dismissal. The meeting continued for another hour, but the outcome was predetermined. Müller's recommendations would not be implemented. As he left the building, Müller encountered Hauptmann Kraus, who'd been waiting. "How did it go?" Kraus asked. "They thanked me for my thorough analysis and ignored every conclusion. What do we do now?" Müller looked back at the ministry building, then at his colleague. "We continue documenting the truth. For history, if nothing else, because when Germany loses this war, and we will lose it, someone needs to understand why. The prophecy was already unfolding on distant battlefields. In the Pacific, American Marines and Army units were island-hopping with Sherman support, their tanks proving invaluable against Japanese forces that had no effective counter. On the Eastern Front, Soviet forces wielded thousands of Lend-Lease Shermans alongside their T-34 seconds. The combination overwhelming German defensive positions through sheer numbers and reliability. And in Italy, American and British forces ground forward slowly but inexorably, their Shermans absorbing losses but always returning, always advancing, supported by industrial production that defied comprehension. Back at Kummersdorf, testing of captured equipment continued. American tank destroyers arrived. Upgraded Sherman variants appeared with improved armor and weapons. Each piece of equipment validated Müller's analysis. American industrial warfare was a system, not just individual weapons. In February of 1944, exactly 1 year after War Daddy II's capture, Müller walked out to the proving ground where the Sherman still sat. 1 year, thousands of test kilometers, ballistic testing, stress testing, teardown and analysis. The tank was battered, scarred, but fundamentally still functional. Nearby sat 3 Panthers from recent production runs. All 3 had suffered final drive failures during initial trials. All 3 awaited parts from overwhelmed supply chains. The symbolism was almost too perfect. Hoffmann, now promoted to Feldwebel, joined Müller beside the Sherman. He'd been assigned to the testing facility permanently, his experience with the captured tank too valuable to waste on frontline service. "I spoke with my brother last week," Hoffmann said quietly. "He's with the 2nd Panzer Division in France. They have 24 Panthers assigned. On average, 8 are operational. The rest are deadlined for repairs." "And they're the lucky ones," Müller replied. "They have access to workshops and parts. Units in Russia are cannibalizing dead tanks just to keep a few running." "Will anyone listen?" Hoffmann asked. "To what we've learned here?" Müller didn't answer immediately. In the distance, another Panther was being towed to the repair shop, its transmission having failed after just 70 kilometers. "The truth doesn't change because people refuse to hear it," he finally said. "The Americans built the right tank for the war they're fighting. We built the perfect tank for the war we wished we were fighting. History will judge which philosophy was correct." Spring of 1944 brought Operation Overlord, the Allied invasion of Normandy. American intelligence, having captured German evaluation documents from Tunisia, knew that Wehrmacht understood the Sherman's capabilities and limitations. They also knew German recommendations for countering the Sherman had been largely ignored. The result was predictable. German armour in Normandy, technically superior, achieved local tactical victories that meant nothing strategically. They destroyed hundreds of Shermans. Thousands more kept coming. Müller received field reports from Normandy with growing despair. Everything his analysis had predicted was manifesting in blood and steel. Panzer units reported higher kill ratios against Shermans, but those units were being ground down through attrition. Mechanical failures rates exceeded combat losses. Fuel shortages immobilized entire battalions. Allied air superiority made movement during daylight suicidal. In July, Müller was contacted by a staff officer from 7th Army, recently rotated back from Normandy. "I read your report on the Sherman," Major Wilhelm Hoffmann told him. "The classified one from last December. I saw a copy at Corps headquarters." "And?" Müller prompted. "Everything you predicted is happening. We kill 5 Shermans, 10 more appear. Our Panthers break down before they reach the battle. Our Tigers sit immobile, waiting for fuel that never comes. The Americans just keep coming." Hoffmann's expression was haunted. "The worst part is watching our crews. They believe in their vehicles. They've been told German engineering is superior. Then they watch their tanks fail while American tanks keep running." "It destroys morale," Müller observed. "It destroys something worse than morale. It destroys faith in the system that sent them to fight in broken machines." By August, with American breakout from Normandy underway, even the most optimistic German assessments acknowledged crisis. The Panther battalions that were supposed to stem the tide had been destroyed not by Sherman guns, but by their own mechanical deficiencies and overwhelming Allied material superiority. At Kummersdorf, Müller drafted a final addendum to his reports. He titled it Post-Combat Validation of Pre-Invasion Assessments. The document methodically compared his 1943 predictions to 1944 battlefield results. Every prediction had proven accurate. The addendum ended with a single paragraph that would later be quoted in post-war histories. "The American Sherman tank has won the war not through superior combat capability, but through superior strategic design. It was built to be produced quickly, maintained easily, and operated by adequately trained crews. These unglamorous virtues have proven more decisive than armor thickness or gun caliber. Germany's insistence on technical perfection over practical effectiveness represents a fundamental misunderstanding of industrial warfare in the modern age." He submitted the document through channels. It was filed, classified, and forgotten by men too busy managing catastrophic defeat to acknowledge that defeat had been predicted and preventable. The final months of 1944 brought Germany's tank production to its peak, nearly 6,000 Panthers and Tigers combined, an impressive achievement given the circumstances. American production that same period exceeded 20,000 Shermans, and 90% of American tanks were operational at any given time, while German operational readiness rates hovered around 40% at best. Müller kept a chart in his office, updated monthly: German tanks produced versus operational, American tanks produced versus operational. The lines diverged catastrophically. In December of 1944, during the Ardennes offensive, Germany's last great armoured push, the story repeated with bitter familiarity. German tanks achieved initial surprise and tactical success. Then they ran out of fuel. Then they broke down. Then they were swarmed by American armour that just kept coming. Hoffmann's brother died in the Ardennes. His Panther ran out of fuel after advancing 15 kilometres. The crew attempted to withdraw on foot. American artillery caught them in the open. "He died believing he fought in the best tank in the world," Hoffmann told Müller when he received the news. "He never knew the truth, that we lost because we pursued perfection instead of effectiveness." As the war entered its final months, Kummersdorf prepared for evacuation. Testing equipment was destroyed or shipped to facilities farther from the advancing fronts. War Daddy 2, that captured Sherman that had survived 2 years of intensive evaluation, was added to a ragtag unit formed from proving ground vehicles. Müller watched as German crews painted Balkenkreuz on the Sherman's hull, preparing it to fight against its own countrymen. The irony was almost too perfect. A tank captured to study American weaknesses, now pressed into German service because American strengths, and operational readiness, TA, made it more valuable than German designs. The makeshift unit, called Panzer Brigade Kummersdorf, saw brief action near Zossen in April of 1945. War Daddy 2, 2 years after its capture, finally met its end, not from American guns, but from its own crew, who destroyed it to prevent recapture as Soviet forces overran the position. Müller survived the war. In the chaos of Germany's collapse, he focused on preserving documents, testing reports, combat analyses, comparative studies. He buried copies in waterproof containers near Kummersdorf, hoping they'd survive for historians. When American forces occupied the area, Müller surrendered to them voluntarily. His reputation as an honest engineer who'd accurately assessed their equipment preceded him. The interrogation was conducted by Captain James Miller, a U.S. Army Ordnance officer who specialized in captured German equipment. "We've read your reports," Miller told him. German. Documents captured in France included copies. "Your analysis was remarkably accurate." "Small comfort," Müller replied. "Being right about losing doesn't change the outcome." Why weren't your recommendations implemented? Müller considered the question. Because accepting them would have meant admitting American industrial philosophy was superior to German engineering tradition. That was unthinkable to men raised in a culture that prized technical excellence above all else. And now? Now, Germany lies in ruins, destroyed by nations that built adequate weapons in overwhelming numbers. The lesson seems clear. Miller showed him photographs. American Sherman production lines, thousands of identical tanks rolling off assembly lines in Detroit, Chicago, and elsewhere. Standardized, interchangeable, reliable. "We almost didn't build these," Miller admitted. "Our own generals wanted heavier, more powerful tanks, something to match your Panthers and Tigers head to head." "What stopped them?" Müller asked, genuinely curious. Practical men who understood logistics, who calculated that shipping weight, bridge capacities, and maintenance requirements mattered as much as gun caliber. Men who decided that 5 adequate tanks were worth more than 1 excellent tank. Practical wisdom, Müller said. Germany forgot practical in pursuit of perfect. In the months following surrender, Müller worked with Allied investigators examining German tank development. His documentation proved invaluable for understanding German decisions that, in retrospect, appeared almost deliberately counterproductive. He participated in comparative testing at Aberdeen Proving Ground in Maryland. War had ended, but engineering curiosity continued. American and British engineers wanted to understand their opponents' thinking. Watching Sherman and Panther being put through identical tests on American soil felt surreal. The results validated everything Kummersdorf had found. Sherman's were individually inferior in certain metrics, but systemically superior in the measures that mattered for sustained warfare. "You built the right tank," Müller told his American counterparts. "Not the best tank, but the right tank. The difference decided the war." In 1946, Müller attended a lecture at Aberdeen where an American tank commander, Lieutenant Colonel Samuel Harrison, described Sherman combat operations in Europe. During questions, someone asked Harrison about German tank superiority. "German tanks were magnificent," Harrison acknowledged. "But war isn't fought by individual machines. It's fought by industrial systems. We had an industrial system that produced reliable tanks faster than they could destroy them. They had beautiful machines that spent more time broken than fighting." He paused, then added, "The Sherman wasn't perfect. We lost too many crews to inadequate armor and guns. But it was good enough, and we had enough of them. That's what mattered." The lecture, Harrison and Müller spoke privately. "I read your reports," Harrison said. "You warned them what was coming. They didn't listen." "Pride," Müller replied simply. The Germans couldn't conceive that American industrial methods might be superior to German craftsmanship. That hubris cost us the war. "Not just Germans," Harrison countered. "Our own generals resisted the Sherman initially, wanted something more impressive, but we had people who understood that impressive didn't matter if it didn't work, or if we couldn't build enough of them. The lesson seems applicable beyond tank design, Müller observed. It's the fundamental lesson of modern warfare. Harrison agreed. Wars are won by logistics, industrial capacity, and sustainable systems, not by wonder weapons and technical superiority. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe. Years later, Müller would reflect on the Sherman evaluation in his memoirs, published posthumously in 1967. The passage was widely quoted in military histories. We examined War Daddy 2 with the arrogance of men who believed our engineering superiority was absolute. We measured its armor, tested its reliability, analyzed its construction. Everything we found confirmed it was inferior to our designs in individual combat capability. Yet, it won the war we lost. The Americans understood something we refused to acknowledge, that industrial warfare requires weapons designed for the conditions of industrial warfare. Mass production, simplified maintenance, operational reliability, these unglamorous qualities matter more than technical sophistication. The Sherman embodied this philosophy perfectly. It was adequate in ways that made it perfect for its purpose. Germany lost the Second World War on many battlefields, but we lost it first in our minds, when we chose to pursue engineering perfection over strategic effectiveness. The Sherman didn't defeat German tanks, it defeated German thinking. That is the true lesson of War Daddy 2, a lesson we learned too late to matter. The captured Sherman, Test Vehicle 259, had revealed truths that German High Command refused to hear. Those truths manifested anyway, written in the wreckage of burned-out Panthers, abandoned Tigers, and the final collapse of a nation that mistook technical excellence for strategic wisdom. In the end, the Americans hadn't built a better tank. They'd built the right tank for the war they fought. Germany, despite all its engineering genius, had failed to do the same. That difference, more than any single battle or campaign, determined the outcome of the war in the West.